right, then we're going to go here. Can I use? All right. All right, so I think I've got everything lined up. So we are going to use these fundamental identities. So what this is it's some trig stuff in that we are dealing with sine, cosine, tangent, cosecant, secant, and cotangent. But really what we're doing today is it's more like a puzzle in that we're sort of going to give you something is equal to something, or it's going to ask you to simplify something. And you use these identities to sort of substitute in to get things to cancel or to simplify or things like that. So what we're really doing is it's more of just like a puzzle where we got to look through these identities and see what's going to help us get what we need to get from there. All right. Oh, there we go. So we are going to recognize and write the fundamental trig identities. We're going to use the fundamental trig identities to evaluate functions, simplify expressions, and rewrite expressions. All right. So this is sort of what's going on here. All right. And go the other direction, introduction. All right, so here it is again. We're going to evaluate, simplify. We'll be able to develop additional identities. We're going to solve trig equations using these things. All right. So here are the fundamental trig identities. You have what are called reciprocal identities, which we've talked about. Sine is equal to 1 over the cosecant. Cosine is equal to 1 over secant. Tangent is 1 over cotangent. All right. And then the other ones. Quotient identities, we've talked about how tangent is equal to sine over cosine. Therefore, cotangent is the inverse, so it's equal to cosine over sine. All right, and then we have what are called some Pythagorean identities, which obviously come from the Pythagorean theorem. Notice it's very similar to the Pythagorean theorem, but what we have is sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. So what we're going to use are we're going to have all these, and it's easier if you have them in front of you. And a lot of times what we're going to do is we're going to take these equivalencies and we're going to substitute one thing in for another that will lead us down the path that we want to get to. And sometimes this stuff is really easy for people to see, and sometimes it's harder for people to see. But like I said, it's kind of like a puzzle. Here are some more identities. The cofunction identities. Sine of pi over 2 minus u is equal to cosine of u. That's basically what that's like. If you look at the sine and the cosine curve, they're like shifted by pi over 2. If you shift the cosine function over 90 degrees, it's going to lay right on top of the sine, but that's why these work out. And then you have even odd identities. If you take the sine of a negative angle, that is equal to the negative sine of that angle. And then you can read through those. I'm not going to read through them all. But we're going to use all these one way or other to fit into the pattern. So here's how we're going to start using them. All right, one common use of trig identities is to use given values of trig functions to evaluate other trig functions. Okay, so here they're saying use the values of the secant of u equals -3/2 and tangent of u is greater than 0. Now where we need to be aware of there is, if you remember, we had our quadrants and I think what we said, all students, something I can't even remember what it was. All students where cosine, sine, cosine, and tangent were all positive. Here, when we have sine, cosine, and tangent, what was it? The sine was, let me pull out my, so I don't mess this up. In that quadrant, sine is positive, cosine is negative, which means tangent is negative. Down here, sine is negative, cosine is negative, which makes tangent positive. And then we have sine, cosine, tangent here. Sine is negative here, cosine is positive, which means tangent is negative. All students take calculus was it. All students, so all are positive. Students, sine is positive, take, tangent is positive, calculus, C is positive. So if the tangent of u is greater than 0, that means the tangent is positive, which means we are looking in quadrant 2 or quadrant 1. And then it also tells us the secant is negative. Now, secant is the inverse of cosine, right? So what we know is because the secant is negative, the cosine is also negative. It would actually be a negative 2/3. And cosine is negative in quadrant. So we know we are looking here in quadrant 3. Okay. But basically what they want us to do is they want us to find the sine of u, the cosine of u, the tangent of u, the cosecant of u, we already know the secant of u, and then the cotangent of u. So we know the secant of u is negative 3/2. Well, cosine is the inverse of that, so we know that is negative 2/3. Okay. Now we can also, we're looking at a triangle that looks something like this, where I guess here is u. Cosine is what? SOHCAHTOA is adjacent over hypotenuse, where the adjacent is right here, which we can ignore the negative on this, but that's 2. This is 3. And then we can use that to find the other one. I think that's where they're going with this. Let me double check, make sure. Let me clear this off. Let's step through, but that's where they're going with this, I do believe, unless there's a, can I erase? Erase all ink. Okay. So using the reciprocal identity, which cosine of u equals 1 over the secant, they're inverses, we know that the cosine is negative 2 over 3. So we had gone there. So let's step through and see how they do. All right, so they're sort of going at it with the, in this direction. All right, using the Pythagorean identity, you have sine squared of u equals 1 minus cosine squared. So what they did is they looked through their identities, and now that we know cosine, they know we can compare sine and cosine here. So notice what can happen is sine squared of u is going to be equal to 1 minus the cosine of u is what? Negative 2/3. So this is going to be negative 2/3 squared, I believe is where they're going to take it. Yep, there it is. Let me get this out of the way. All right. So that's going to be what? 4/9. 1 minus 4/9, which is 5/9. All right. Now, here's where we got to be careful of the sign. Because secant of u is less than 0 and tangent of u is greater than 0, we already found out that it lies in quadrant 3. And we know all students take and in quadrant 3, we know sine is negative. Now, this isn't simplified yet because we have sine squared of u. We're going to have to take the square root of both sides, and what we're going to end up with is the sine of u is going to be equal to the square root of 5 over 3. Does everybody see that? And it's going to be negative because we know we're in quadrant 3. Moreover, because sine of u is negative when using quadrant 3, you can choose the negative square root in time. So there we go. So now we have the secant and cosine from what they gave us and taking the inverse. We now have sine. Now we're going to be able to find cosecant of u because it is equal to 1 over sine of u, which basically means I just flip this around. That means cosecant of u is going to be equal to negative 3 over the square root of 5. Now, they're not going to want us to leave it, the answer with a square root in the denominator. I don't believe. I know they've done that some in this other, but when we're simplifying here, what we've got to do is we've got to rationalize it by multiplying the top and the bottom by the square root of 5. And we're going to get negative 3 square root of 5 over 5. I believe that's where they're going to take this. Let me clear off the ink. So there we go. Negative 3 over square root of 5, and then that equals negative 3 square root of 5 over 5. These scientific calculators we have in the classroom will simplify square roots, or simple if you have any of those, if you don't feel like going all the way through the process, although it's not hard, just multiplying top and bottom by the square root of 5. All right, now how are they going to get to tangent and cotangent? We've got sine, cosine, secant, cosecant. Well, we have those identities that say, well, tangent is equal to sine over cosine. So from there, and this is what they're going to do next, tangent of u equals sine of u over cosine of u, which, what did we say the sine of u was? The sine of u is negative square root of 5 over 3. And we said the cosine was negative 2/3. So what we end up here is, since both 3's are in the denominator, they basically cancel with each other. We got negative square root of 5 over 2. So we end up with the tangent being the square root of 5 over 2. And then we know the cotangent is the inverse. And so this is going to be 2 over the square root of 5. And then I've got to rationalize again. And I get 2 square root of 5 over 5. So now, based on just the one value given us of secant u is equal to negative 3/2, and telling us what quadrant, or telling us that the tangent is positive, which tells us it's in quadrant 3, we've been able to figure out all 6. Is that all there is on this PowerPoint? All right. There's going to be more to this, I do believe. So what I'm going to do is I'm going to pull up let's get out of that. Let's see. Where is WebAssign? Let me see if I can't pull up the assignment and get some of the problems. But that's basically what it's dealing with, is using these identities to get the things. Let me look in the book too. And we may just have to do something out of the book. This is chapter 5. All right, assignments. Let's look at some more of this. There's 5.1. So let's view. All right, so let's step through. So right here, this match each function with equivalent expression. So that's just pulling off those papers, the identities, what equals what. What sine of square root of u equal, you find cosecant. That's all these on here. Now on the sine of u, the identity is sine squared of u plus cosine squared of u equals 1. So you just have to get sine squared of u by itself by subtracting cosine of u to each side. There's the identities. You just fill in based off looking at the identity. And then the rest of it, it looks like it is that's just comparing identities, asking us to simplify. Now, here's one that we probably need to go over. All right. So let me see if I can get this. I don't know why it's doing that. Let me see if I can. All right. So that's not exactly what I wanted to have happen. Well, here it is. It's got 5 secant squared of x, 1 minus sine squared of x. And they want us to simplify. Okay. So what I've got to do, this is where I'm talking about it's sort of like a puzzle. I need to look on there. Is there some way I can get a secant squared to cancel, or can I get the sine squared to cancel? And things like that. So what I do know is using this identity, sine squared of u or x, it doesn't matter, plus cosine squared of u equals 1. That means if I subtract cosine squared from both sides, I'm going to have sine squared of u is equal to 1 minus the cosine squared of u, which isn't going to help me. Now I could substitute in 1 minus cosine squared of u there, but I actually, if I would have done it this way instead of that one, let's solve for cosine squared of u, because watch what happens when I solve for cosine. If I subtract sine squared of u minus sine squared of u, I get cosine squared of u equals 1 minus sine squared of u, which is right there. 1 minus sine squared of u is equal to cosine squared of u. So what I can do is I can change this, right? Simplifying means get rid of parentheses, combine like terms, things like that. I can take that and I can replace it with cosine squared of, and I'm using x, not u, sorry. So because cosine squared of x is equal to 1 minus sine squared of x, I can replace that. Now, if I look at secant, here's what I know. I know secant is equal to 1 over cosine of u. So this is going to be a comparison of secant and cosine. They're both in this identity. So what I also know is true is that secant squared of x is going to be equal to 1 over cosine squared of x times cosine squared of x, which I could write that over 1. And then notice that's going to be 5. If I multiply these fractions together, I'm going to get cosine squared of x over cosine squared of x, which we know this cancels and cancels, and I end up with 5. So this is how they ended up getting this simplifies to 5. All right, let's look here. Here's the answer of 3 tangent of theta. So they've got 3 secant of theta over cosecant of theta. So if you go and look, what can we do with this secant and cosecant? Is there anything that compares secant and cosecant? There's not, but I also know secant and cosecant are both associated with sine and cosine, and sine and cosine are associated with tangent. So what if I look at secant? What is, this would be 3. How could I rewrite secant? Well, secant is the same as, this would be 3, and this would be 1 over cosine of theta. And on bottom, I would have 1 over sine of theta. All right. So everybody, secant is equal to 1 over cosine. Cosecant is equal to 1 over sine. Now, to simplify this where I don't have fractions within fractions, this is basically going to be 3 times 1 over cosine of theta times, right, when we divide, that's what fraction is, dividing. Whenever we divide by a fraction, we multiply by its inverse. So I've got sine of theta over 1. And then when I simplify that, I've got 3. When I multiply 1 times sine, I get sine of theta. And cosine times 1 is cosine of theta. And then now, what's sine over cosine equal to? That is equal to tangent. So what I end up with is 3 tangent of theta. And that's how they simplified that down. So that's what I'm talking about. What these are sort of puzzles. Is you look and see what you have. What can you change it to that would allow something to cancel or would allow it to equal to something else that I can relate it to? And let me see if I can get back over. That's really the same thing there. So let's see what was up here. All right, let's look at this one right here. And then this should be, that's not what I want. All right, so they tell us cosecant of theta is equal to 2 square root of 3 over 3. And they also tell us tangent of theta is equal to the square root of 3. Now, if we look at all students take calculus, cosecant or tangent being positive means that it has to be either in quadrant 1 or 3. And cosecant is associated with sine. It's also positive. Well, sine is negative in 3 and positive 1. So this, we know this is in quadrant 1. So everything's going to be positive. Okay. Now, we can easily find cotangent because it's the inverse of this. So this would be 1 over the square root of 3, which would equal, if I multiplied top and bottom by the square root of 3, I would get that to be the square root of 3 over 3. All right, now cosecant is the opposite of sine, right? Inverse. It's 1 over sine. So what I know is sine of theta is going to be 3 over 2 square root of 3. Then I would need to multiply the top and the bottom by the square root of 3. And that would be 3 square root of 3. And 3 square root of 3 times square root of 3 is 3 times that 2 is already there, which is 6. And then 3 over 6 simplifies. This is going to be the square root of 3 over 2. So we've got sine, we've got cosecant, we got tangent, cotangent. Now we've got to figure out cosine. Is there information here to find cosine? Well, what we know is the sine squared of x plus the cosine squared, let's see if this one will get us there, is equal to 1. And if we know sine is square root of 3 over 2, so the square root of 3 over 2 squared plus cosine squared of x is equal to 1, then that's going to be what? 3/4 plus cosine squared of x equals 1. I subtract 3/4 and I get cosine squared of x is equal to 1/4. I take the square root of both sides and I get the cosine of x is equal to 1/2. Cosine of x equals 1/2, which means the secant is the inverse of that. 1 over 1/2 is 2. So there we go. That's how we step through that. So that's basically all that's happening. Find out which quadrant it's in by what's given. Then you know what's positive and negative, and then you use these little identities to iron things out. All right, that's basically what's happening all the way through. So let me go ahead and